Hello dear students, this is the first lecture of our third unit, that is magnetic effects of current, and I will discuss with you what is Oersted experiment, and second point I will discuss with you in this video lecture, Biotin-Savart law and force on a charge moving in magnetic field. So these are the first three introductory topics, and the starting of units, so other definitions which will come in between I will discuss with you. So the first thing in magnetic effects of current is Oersted experiment. So in Oersted experiment, what Oersted stated, you must have studied this experiment in class 10th also. If a magnetic compass is placed below a current carrying conductor, in which current is flowing from south to north, then north pole of the compass needle will deflect towards west. So if this is your compass and this is your compass needle, north pole, which is generally represented by red color, and then you are having your south pole, the north pole of the needle and the south pole of the needle, and they are placed, the needle is placed below a conductor in which current is flowing from south to north direction. When you switch on, it is connected to a battery, and when you switch on the battery, the current flows from south to north direction. Then the north pole of the needle will give you a diffraction towards west direction, and south will go towards east. Let me draw the directions for you: north, south, east and west direction. So you can also remember this Oersted experiment by the word snow, which means current is flowing from south to north and needle deflect towards west. So you can identify these words here. Current is flowing from south to north, then the needle of the north pole of needle will deflect towards west. So with this one word S, N, O and W, you can remember the definition. Current is flowing from south to north and the needle will deflect towards west. Needle will deflect towards west. This is known as Oersted experiment. This is the first law. What is the significance of Oersted experiment? It was the first experiment which gave you direct relation between magnetic field and current, and this experiment also demonstrates that current carrying conductor is a source of magnetic field, because only magnetic field can affect a magnetic needle. So this experiment is very important from this point of view. So have a look here. This is a compass in which the needle is red color is representing the north pole and the needle is resting towards north. This is a battery. This side is the plus terminal and this side is the minus terminal, and this is a wire in which current we will make the flow of current from south to north direction. So if I will connect this end to the negative terminal of battery, I can place markers here for making it in rest. Yes, so this wire is like this, and when current is flowing from south to north, this is the plus terminal, so I am connecting this point here, and the other point of the wire I am going to connect here. So when current will flow from south to north direction, you will see needle will deflect towards west. So needle will deflect from towards west direction, you can see. So you had seen the deflection in west direction. So as you just have seen the deflection using a simple wire, a lithium ion battery and a magnetic compass. I had shown you how when current was flowing from south to north direction and the deflection was towards west direction. So what this rule is indicating, what this rule is telling, this rule is giving us very important information about the direction of magnetic field which is involved. So if this is the wire in which current is flowing from bottom to top and your thumb is pointing in the direction of current, then curvature of fingers will give you the direction of magnetic field. So look here, if this is the conductor, at this point magnetic field will be coming towards you out of the board. At this point it is going from your left to right. At this point thumb is in the direction of current, magnetic field is into the board. And if you will talk about the magnetic field behind this wire, you are on this side of this wire, and on the behind this wire the magnetic field is like from right to left. So when magnetic field is right to left, we all know that that magnetic field is corresponding to north to south. So as north repel north, so this needle was deflected towards west. So this is very interesting to know here. So, this concept which I am just discussing with you, that thumb is pointing in the direction of current and curvature of finger is giving us direction of magnetic field. Magnetic field is in the form of concentric circles. This is also known as right hand thumb rule. So that is the second point of discussion, which is right hand thumb rule. So if you are having a conductor in which current is flowing in a particular direction and if we will keep our thumb in that direction, then curvature of fingers, my drawing is not that good, excuse me for that. Then curvature of fingers, the conductor is in your hand, then curvature of fingers will give you deflection, direction of magnetic field, the curvature of fingers. So this side of conductor, it is coming towards you, and on this side the direction is going into the board. So it is not like this or like this, it is going into the board like this. So this direction on this board I can show like this only. So using this diagram we can draw the magnetic field lines around a conductor in the form of concentric circles, and that is known as right hand thumb rule. This right hand thumb rule is also known by many other names, like this is also known as Maxwell's corkscrew rule. It is also the same. It is also known as right hand screw rule or right hand palm rule. So all these names are representing the same phenomena which right hand thumb rule is representing. So do not need to confuse, take a break here. All these rules are indicating the same thing, the direction in which magnetic field is being produced by the your current carrying conductor. So the third topic is force on charged particle in magnetic field. So consider this is your magnetic field which is represented by B, and this is your charged particle Q which is moving with velocity V, and they are having theta angle. Then the force on the charged particle F is directly proportional to the magnitude of charge. Force on charged particle is directly proportional to V sine theta, and force on charged particle is directly proportional to magnitude of B. Combining these three equations, we can write force on charged particle is directly proportional to QVB sine theta. When we remove directly proportional, a constant come every time, but this time the constant is 1 in this equation. So F is equal to QVB sine theta. So this equation gives you the magnitude of force on a charged particle Q which is moving with velocity V, making angle theta with the magnetic field B. You memorize this formula, this is very important. From this equation we can analyze two things. First, We can analyze the definition of magnetic field, which is a new quantity in our discussion, because in first unit we were discussing about electric field only. This is magnetic field now. Second, this equation can provide you the direction of the direction of force which is experienced by charged particle. First, let us focus on the definition of B from this equation. So if your F is equal to QVB sine theta, you can always write like B is equal to F divided by QB. Sorry, B is there. So F is equal to QV sine theta. Now consider this equation, and in this equation if I will consider few parameters, like if my F is equal to 1 Newton and my Q is equal to plus 1 Coulomb and my V is equal to 1 meter per second and my theta is equal to 90 degrees, so that my sine theta will become 1, because theta is equal to 90 and sine 90 will become 1. So this equation will reduces to B is equal to 1, because F is 1, Q is 1, V is 1 and sine theta is equal to 1. Or if I will keep this as F only, will not provide this any particular value, so my B will become equal to F under these special conditions. When your Q is equal to 1, V is equal to 1 meter per second, theta is equal to 90 degree. So how this equation is helping me in defining B? So the strength of magnetic field at any point is equal to the force experienced by the charge if it is moving with velocity 1 meter per second, having magnitude 1 plus 1 Coulomb, making angle 90 degree with the direction of magnetic field. The force experienced on that charged particle is equal to the strength of magnetic field there, or magnetic flux density there. So this equation is helping you defining magnetic field. Unit of magnetic field is Tesla, and you can define like the Newton per Coulomb meter second, Newton second per Coulomb meter. That is also the unit of B, but that is collectively known as Tesla. Like 1 Newton per meter square is known as Pascal. It is named after great physicist Nikola Tesla. And second point which I told you about the direction. How can we find out direction? If I will write this equation in vector form, it is going to be like this. F vector is equal to Q V cross B. And you cannot change the order of this cross product, because we know that A cross B is not equal to B cross A. This is V cross B. And in class 11 we have studied about the cross product and how to find the direction of vector resulting from cross product. So F is the vector which is resulting by the cross product of V and B. So if we are interested in finding out the direction of V and B, we imagine a right-handed screw here. Right-handed screw का क्या मतलब होता है? सीधी चूड़ी वाला स्क्रू. यानी कि अगर आप उसको खोलोगे एंटी क्लॉकवाइज तो वो बाहर आएगा, और आप उसको क्लॉकवाइज घुमाओगे तो वो अंदर जाएगा. हम V क्रॉस B निकाल रहे हैं तो हम V से B की तरफ जाएंगे. अगर हम यहाँ पे इमेजिन करें कि हम एक स्क्रू को रखकर एंटी क्लॉकवाइज घुमा रहे हैं, खोल रहे हैं, तो वो स्क्रू बाहर आएगा, तो V क्रॉस B की डायरेक्शन जो है वो बाहर की तरफ आ जाएगी. अगर इफ द केस वुड हैव बीन लाइक दिस कि हमारा V जो है वो ऊपर होता और B हमारा नीचे होता वेक्टर, फिर अगर हम V क्रॉस B डायरेक्शन की बात करते तो वो डायरेक्शन हमारी जो है V क्रॉस B जब हम करते क्लॉकवाइज घुमाते तो वो अंदर जाता इनटू द बोर्ड. तो जनरली हम इनटू द बोर्ड को डॉट से रिप्रेजेंट कर देते हैं, परपेंडिकुलर इनटू द बोर्ड. अलग अलग बुक्स में अलग अलग नोटेशंस यूज की जाती हैं, तो ऐसा कोई फिक्स नहीं है कि डॉट हमेशा परपेंडिकुलर इनवर्ड दिखाएगा और क्रॉस हमेशा परपेंडिकुलर आउटवर्ड दिखाएगा. बट ओके, लेट अस मेक दिस कन्वेंशन हियर that cross is representing the direction perpendicular out from the board. Okay, so we have figured out the two things. The first is the definition of B from this QVB sine theta, that is the force on charged particle Q moving with velocity V making angle theta with the magnetic field B, and we can also write it in vector form and can find the direction of force, that is V cross B in both cases, and definition we figured it out.